Kunle, you unmute yourself, Kunle.
To unmute myself. That's true.
Yeah, that's good.
Can
Yeah.
you hear me now?
Yeah.
Can you hear me now?
Yeah.
Okay. So I'm just saying that, yeah, doctor to be indeed. Hopefully, I'll be able to defend my PhD in the next 5 months or so. And maybe I can call myself a doctor. So then I'm still Mr. Adekunle Ajayi, I guess.
Yeah. Yeah.
I can hear myself, and I think there's some echoes.
I think
Background
it should be good now.
Okay, great. Yeah, so thanks for that introduction. And yeah, I'm actually glad to be giving these presentations today. And I'm just going to be talking about something probably most of you have heard about or you already know, but just in another way, just to let you know it more. So I'm going to try to be on full mode now. Can you see my screen?
Yeah.
Okay.
Yeah. What about other people? Can everyone see the screen?
No.
Are you using your phone?
Yes, I'm using a phone.
But can you see any video, or you're just connected via the sound?
No, I can see him. I can see Adekunle, but okay. I can't see the screen.
Okay, maybe I'm going to like stop my video. Can you see my screen now?
Yes, awesome. I can see it.
Okay, yeah, okay. So can everybody see my screen now?
Yeah. Yes, I can.
Okay, great.
All right.
Just a minute. I'll drag this out and I play this. Okay, great. So today we're just going to be chatting about how to write good codes because I realized that as scientists, whether we like it or not, if you're doing something scientific, you get involved in a lot of activities, most of which actually involve you writing scripts for different purposes, which I will try to highlight in the course of this presentation. And this presentation today is part of a 2-series presentation, which is under the theme Introduction to Scientific Computing. And today is dedicated basically to for us learning more on how to improve our codes and how to write clean codes. And I'm very grateful for Yemi for actually telling me to do this. It was more of a discussion between myself and him, and we came up with this beautiful idea to give this presentation. So thanks, Yemi, for your very nice idea and a platform to give this presentation. So what is scientific computing? Since this is a series under the theme scientific computing, we should be able to understand what scientific computing is. And I'm not going to be saying anything complex. I'm just going to be saying things with simple terms for us to be able to get as much as we can from this presentation. So just a minute. I have a problem with the, I think I'm just going to minimize this. Okay, great. Yeah. So I was saying, what is scientific computing? And basically, in simple words, scientific computing is just a science of solving problems with computer. It's as simple as that. Just using the computer resources to solve your problem. Your problem might be for industrial purposes. It might be for academia. It might be for whatever need that you want. But basically, you're just using the resources that computer has to solve your problem. And for us in the academia, we have a lot of scientific problems that we use computers to solve. But how do we really do that? We do that by first developing algorithm, trying to understand our problem, trying to translate into mathematical models, trying to use logic and the way we understand that. And we develop an algorithm to say, okay, if we have this algorithm, you should be able to solve this particular problem. After gaining an insight into the algorithm, we implement this algorithm by talking to the computer. And how do we talk to the computer? In layman words, we say we do programming. And most of us as students, as lecturers, we are actually at the right side of this screen, whereby we hold on to our system with a cup of coffee to the right, or tea, if you don't drink coffee, and we try to talk to the computer. And we talk to the computer by writing codes. Some will say you're writing script, but this is all an act of what? Programming. And we talk to computer in different ways. That is, we use different languages. As a matter of fact, right now we have over 700 programming languages, and I've just listed some that are very famous, which include Python, C++, R, and MATLAB that I believe that everyone is very familiar with. Just for the record, feel free to stop me or interrupt me if there's anything you need clarification. Am I clear on that?
Yeah.
Okay, great. So Python, C++, R, these are computer languages that we are very familiar with. But because I'm at the moment using Python, most of my examples and illustrations is based on Python. But the truth is the assumptions or the general information from this presentation is also adapted to different programming languages. So in academia, why do we write script? Why do we do this act of programming? What does programming really mean for us? Yeah, with my little experience and my interaction with a lot of people, I've realized that in the academia, we write script mainly to run experiments, that is to do numerical simulation. For instance, in the atmospheric and oceanic communities, one of the ways we try to understand the ocean and the atmosphere is by running experiments based on numerical simulations, trying to make weather forecasts, trying to simulate ocean quantities or atmospheric quantities. And these things are brought about by writing a lot of script, be it in Python, be it in Fortran, yeah, depending on the language in which you understand most to talk to this computer. And also, we write script to do data analysis. After running these simulations, we get a whole lot of data set, and we try to make sense of this data set. One way we try to do that is writing script to do some data analysis and trying to get insight into this data set. While we are doing data,
1 second before you go ahead, I just want to ask Mary and Marissa, do you guys use coding to do your work? And if you do, what kind of code do you use?
Okay, yeah. For me, I most of the time I write in Python.
Okay.
With a little bit of Bash, that is, I try to interact with the terminal, but
Bash,
more
yeah,
with
Bash
Python.
script.
Yeah, so I do more of Python. I write codes in Python. My analysis, my visualization is in Python. But the numerical simulations that we do in my lab is based on Fortran codes.
I see. What about Marie and other guys? What kind of code do you use?
For me, I use R to analyze some data and
okay, good.
For doing my maps. Now I'm learning Python. I think so.
Oh, that's very good. So you're gonna get a lot from this stuff then, because you're learning Python. What about Henry? Henry, do you use what do you use? Do you do coding? All right, I think Eric you cannot hear us. All right, anyway, continue.
Thank you for that. So yeah, it's good to know that at least we have in the audience students that are familiar with this act of coding by using R, by using Python. So yeah, we are quite clearly on the same page. Yeah. So just to summarize what I'm trying to say here is that we use script for a lot of things, and it involves data analysis, data visualization, and some projects as well involving software development, because there have been this growing community of scientists that think that we shouldn't just write script and throw them away. We should be able to put this code together and so that it can be reproducible and other people can use it and install it easily. So having said that, why do we really want to write a clean code? Can you see my headlines on the slide?
Yeah.
Okay, because for me the
we can see it.
Zoom panel is okay. So if you can see, that's fine then. So why do we really need to write clean code? I'm just trying to summarize this with just 3 sentences. You want to write a clean code because you want to be able to share your code with anyone. I've come across so many students and scientists that are not proud of sharing their codes because it is messed up, because it's not clean, because after a while they themselves don't understand it again, and it's totally fine. They're not alone in that problem. There's a whole lot of people in that same situation. Also, you want to write a clean code because you want to be able to reuse your code after a long time. Like I said before, there are so many people that are breaking codes, and 6 months, 1 year, they go back to the code and they don't really understand what they wrote the code for, how they came about the code. It has happened to me before, and it has happened to a lot of people as well. But by writing clean codes, you are going to be in command of your script, and 2-3 years after, you can go back to your script, and by just looking at it, you can have a clear understanding of what the code is doing. So at the same time, you want to write a clean code because you want to be able to manage and debug your code easily. One of the problems in programming is debugging. It's much easier to write code, but debugging is a nightmare. So if you don't write a good code, then, or a clean code, then you're going to waste a whole lot of your time trying to debug your code. So now we've learned that, yeah, we have reasons, we have motivations why we really want to write a clean code. But in reality, what does scientific codes look like? Or maybe not scientific codes, what is the typical code by a scientist or by a student looks like? So now I'm going to show you two functions, and I'm going to give you 5 seconds each for you to look at this function and tell me if you understand what this function is doing and which one do you prefer. So this is the first function. It's very small at the left top corner. I don't know if everyone can see it. Yep. Can you see it?
Yeah.
Okay, so 5 seconds starts now.
I don't know about everyone else though.
Okay, can everyone see?
Mary?
Yeah.
Okay. Okay, so I'm going to give you 5 seconds to look at this function and tell me what it does. So just keep that to your mind. And I think the 5 seconds is up now. So I'm going to show you this second script, which is also a function. And I'm going to give you 5 seconds to look at it and tell me what you think that function is going to do. So are we there now?
Mm-hmm.
Okay, so which of this function do you think, or what is this function, what are these functions doing, or which one would you prefer if you're supposed to write this function? Or if you're supposed to get it from somebody, which one would you prefer to get from someone?
The first one, of course, because it's not long.
Code A or code B?
Code A.
Code A, okay.
Yeah, the code B will be better because it's well commented. Like you have more comments in it.
No idea.
Okay, no idea.
I don't know about code.
Okay, it's all right. It's not like putting you on your hot seat. It's just feel free and just.
Yeah,
so, now, for me, and going by the norms of how to write good codes, I think code A is not a good code. Because one, code A is not even telling you what the code is about. You don't even know what the code is doing. You just have a bunch of syntax there and some return keywords. On the other hand, code B, from the code itself, you know what the code is doing. It's telling you compute distance between 2 points. And that I can read that in 1 second. And in 2 seconds, I can go to the next line and say, okay, what is this function doing? This function computes the distance between 2 points on Earth using Adebiyi formula. And that's what you want your code to be like. You want to write a function, a script, that it's self-explanatory, that people can see and understand in 5 seconds what this script is going to do or what I'm going to use this script for. So I haven't realized that we don't want to go in the line of code A, we want to go with code B. What are the things we need, or what are the skills that we need to put in place, or the concept that we need to follow to write a good and clean code? So what are the tips for writing clean and reproducible codes? And this is what I'm going to try to answer in the next couple of minutes with you. First, you need to use a self-descriptive name. And what do I mean by that? Your functions, your variables, they need to speak for themselves. You need to write the name as you would speak it. What is my function? What exactly do I want to do? I want to write a function that computes the distance between 2 points. So write the name of your function like that. Compute distance between 2 points. It's as simple as that. And whoever sees your function's name knows that, okay, this is what the function is going to do. Are you with me?
Yes.
Yeah.
Okay. So, and you might be thinking, okay, compute distance between 2 points. Probably that's too long. No, it's not too long. Going by the quote of Robert C. Martin, a long descriptive name is better than a short enigmatic name. You don't want to just write cal distance, calculate distance. This sort of naming doesn't give value to your script. I know most of us will do this, but it's not an acceptable norm towards writing good codes. You need to write things the way you would speak it. Also, for the variables, you need to write the variables the way they can be pronounced, not lat. It's latitude, so write it as latitude. It is longitude, so write it as longitude. So central angle, write it as central angle and not cent angle. So things like this is going to give elegance to your script, and it's going to make your script much, much cleaner and much, much easier to understand. The next thing you need to do is this. You need to use documentation string. What is documentation string? When you're writing a function, whoever is going to be using your functions in the next 5-10 years should be able to understand clearly what your function is doing. And he or she would not understand if there is no place in that function for to describe to such a person that this is what my script is doing. That is why this doc string in the red box clearly states what this function is all about. And I write there that this function computes the distance between 2 points on Earth using Ajayi formula. And it goes on to tell you the Ajayi formula determines the, okay, I'm speaking Italian now, determines the great circle distance between 2 points on the sphere given their longitude and latitude. This is clear enough for anybody that gets your script to understand that this is what your script is doing. And this is what is also missing in the code A that I showed you before, which is just a bunch of lines with nothing to explain what the code is doing. So your doc string should describe what the function does and not how. And in fact, it should give a clue as to the input that the function takes, which is there you see the input, longitude, latitude, and should give the output, which is the return, that what the function is going to calculate and what it's going to give to you, which is the distance. And also additional information such as the unit and the unit of the quantities you get putting in and the quantities you're getting out. So this is very important. And all your functions that you're writing, if you're writing a big software that contains a lot of functions, should have a doc string. Like that, if you come back to your script, say the next 2-3 years, you understand perfectly well what your functions are doing, and it makes debugging very easy for you to do. Say for instance, I put this function, which is compute distance between 2 points, with the other function that I wrote before, which is this that I showed you, the car distance, and I put both of them in a Python script, and I save it in my system. I save it, say, on the folder in my system called document, and I name this script. I call it Ajayi function, and I try to import this script onto Jupyter Notebook. I'll pause here. How many of you know about Jupyter Notebook?
I don't think so many people.
I've heard that once, but sincerely, I don't remember.
Okay. In my next presentation, I'm going to talk about Jupyter Notebook. For now, just understand Jupyter Notebook as a platform where you can do programming interactively, whereby you can put in the code, you can get the output, you can plot, you can write notes. Just see it as a diary of a programmer, whereby you can do so many things at the same time. You can run your script, you can write comments, you can write notes, you can plot the images and things like that. So now I'm using a Jupyter Notebook, and I'm importing that script that I've written called Ajayi function, and I'm importing it as HF. And don't worry about the HF. This is just a typical way we code in Python. So I import this function, and I know in HF I import this package rather, and I know in HF, which is Ajayi function, I have Ajayi package. I have a function called compute distance between 2 points. But I don't know what this function does because I didn't write this function. I just want to try and understand it. By putting the question mark or writing help this function, and I press Shift Enter, it returns to me the doc string of that function. So even if I didn't write this script, I clearly understand what this script does, and I know the two quantities that I need to give into these functions and what I'm going to get in return. And that's one of the advantage of writing doc string to all your functions. In the other way, let's say the other function, cal distance, which I did not put any docs for, and I try to import it as well. And I say HF cal distance, and I do shift enter. And this is what I get. And if I did not write this script, then it's difficult for me to use this script because I don't know what it does. I don't know what it takes as input. I don't know what it takes as output. So this clearly highlights to you that putting docstring in your function would help you a lot and also help whoever is going to be using your function. Okay, that is about docstring. Also, you need to, okay, you need to write good comment. I can't see the labels myself. Okay, you need to write good comment, and that's very important. That's important because you want your code to be self-explanatory. You want to come back to your code 2 years' time and understand exactly what you did. You want to pass your code to somebody else, and you want the life of that person to be very easy going through your code. You want debugging to be easy, so you need to write good code. Now, here I wrote convert degrees to radian. That's because I'm converting the latitude, which is in degrees, to radian. I'm converting the longitude. It's very important I write that so that whoever gets a hold of my script will understand what I'm doing. Also, I said implement Ajayi formula. Without me putting that there, that line is just a bunch of codes that you don't know anything about. As a matter of fact, if you don't understand what Ajayi function does, then you don't understand what I'm doing without me writing that comment. So if you want to pass your code across to someone, you want to make the life of that person very easy. So putting that comment there would help the person understand that at this point, I'm implementing Ajayi function. And after that, I'm going to compute the central angle, which also I've written a comment there to show you what that line of code is doing. While we are emphasizing that you need to write good comment, also, you should not write bad comment. Yeah, you might be surprised. There's what we are things we call bad comments, because while you're trying to write good comments, you might tend to put comment where you actually don't need comment. Now, remember, we talked about using descriptive names. If your variables have self-explanatory names, self-descriptive names, then in some lines of codes, then you don't need to add comment. And for example, here, I said compute distance. This is very clear enough. Distance is equal to arc radius times central angle. There's no point writing compute distance. That's clear enough. Round up distance to 2 decimal places. If you are going to be interacting with my code, np.round is clear enough to understand that I want to round this up to 2 decimal places. So there's no point writing compute distance, round up distance to 2 decimal places, because if you're writing a very complex software that involves thousands of codes, you don't want to put too much comment as well. You want to be able to optimize between the numbers of comments you have and numbers of clear and easy to understand lines of codes you have. So avoid redundant comments, because that is not going to make that line further clear. It's clear enough on its own. So writing comment is very, very important, and it's an habit that every programmer should cultivate. 3, you need to be consistent with your coding style. That's very important. If you see in my code, on the left, our code has been written with underscore, compute distance between blah, 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 as I've shown before. On the right is a code that has been written with capitalizing the first word, or even in a phrase. For instance, great circle distance, earth radius. And you see that I'm very consistent with this concept, earth radius, central angle. Is either I merge them together in the right-hand side, or I separate them with an underscore. This is very important because this is going to make your script very clean and easy to understand as well, because there'll be consistency in the way you name your variables, and there'll be consistency in the way you have defined things. So this is also something you need to take into account when you are writing a very good and easy to understand script. And this is applicable to other programming languages. This is not just for Python alone. This is applicable to other programming languages, C, R, MATLAB, whatever programming language you're using and you're familiar with. So the next one, you need to break or give one function. Do you have a question? Hello?
Hello, Marie. Is it that Marie? Does anybody have a question? I'm not sure. If you want to ask a question, you can unmute though.
Okay. Maybe no question.
Oh, sorry. I have a Skype call. That's why I made my.
Okay. Okay. So can I continue?
Yeah.
Yes.
Okay.
Yes.
So I was saying one function, one task. This is very important. In my previous slide, I've shown you a script, a function that computes the distance between 2 points, giving the longitude and the latitude. Now, I want to go further. I want to compute the distance for so many files, for so many, not just for one file, but just for so many files. And I can get the latitude and the longitude from this file and compute the distance. What I will do is to create another functions that loop over all those files, gather the distance, that append the distance to a list array, and then convert it to a numpy array. I have decided to take out the comments, the doc strings, just to fit this function into the screen so that you can see clearly. If not, they would have all the necessary part that makes up a very clean and easy to understand code. So you will see that I've created another function, get argo float distance array, and I'm calling the first function in the second function. I could have said, okay, I'm just going to add all these things together, loop over in one script, but no, it's easier for me this way because I can understand what each function is doing. And let's say, fine, after getting the distance associated with each file, I want to calculate the statistics from this distribution of distance that I have. I want to get the mean, the median, the max, and things like that. I can write another function called compute statistics of distance covered. And I can supply the same quantity called the argo files, and I can get the distance array. I can compute the mean, the median, the max, and I can return argo statistics. And in this a function called compute statistics of distance covered, I can call get argo distance array. And you can see that the argo distance, the third function is calling the second function, and the second function is calling the first function. By so doing, it's going to be very easier for me to monitor what each function is doing, for me to debug, and it's neater this way than just putting everything together. So in the acts of programming as well, you want to be able to break your programming problem into many small functions with specific tasks. Most of the software that you have installed on your system that are doing different things are not just one giant script. It's just so many functions combined together. And that way, your code is going to be clean, neat, debugging is going to be easy, and anybody that wants to understand what you've done will find it very easy to understand and comprehend the objective of your script. At this point, is there any question?
Just to remind everybody, if you have questions, you can easily unmute yourself. Somebody has a question. I think, yeah, Bastien. Yes, hi.
Yeah, I want to ask argo statistics.
Okay.
Is that the data frame that you are calling?
No. It's just a file. Argo statistics, yeah, I said get argo float distance array. So I'm getting the file, and remember in get argo float distance array, I'm getting the file and looping over the file. It's just like a NPZ.
Where you have
What do you say?
So the file is where you have your coordinates with your lat longs.
Exactly.
Okay, and then from there you are using the built-in functions to compute the statistics.
Exactly. Yep.
Yeah, I just want to, can you quickly give for some people that are just joining us, can you give some kind of a quick rundown of what you've done, what you've talked about so far so that they can catch up? because a lot of people have been joining in between. So just
okay, sure. So basically, for the past few minutes, I've been talking about the tips needed to write clean codes. And what I mean by clean codes are scripts that you can share with anyone. That's very easy for you to debug. It's very easy for you to reuse. And what are the things you need to do to write these clean codes? One of the things I've said before, that you need to include comments. You need to be able to write good comments. You need to be able to write, use a self-descriptive name. For instance, if the variable is called latitude, you should use latitude and not lat. If you want to compute the distance between 2 points, as it is in the first function, you should use the function name the way you can speak it. That is, compute distance between 2 points, and not calculate distance or cal point, things that are not self-explanatory, because the overall objective of you writing a clean and reproducible code is that whoever gets your code can use it without you being there. So the more point is you need to be self-descriptive name. You need to use, you need to write comments. You need to include docstring, and the docstring is actually the words that are in red there, showing or telling anybody what that code is going to do. So I think those are the 3 points that I've mentioned before. Okay, I just quickly look at others. Okay, and I talked about keeping a consistent coding style, which is just trying to be consistent with the name of the, if it is changing latitude with an underscore or delta latitude altogether, be consistent with the way you write your code. It's very important. It's going to make your code very easy to understand. It's going to give your code elegance, and you will like it as well. So yeah, I'm just trying to emphasize why you need to have or break your problem into so many functions, because like that, it's going to be easier to understand. It's going to be easier for you to debug your code, and you can edit a part of the function without overall affecting the entire objective or the entire code itself. Is that clear to those that have just joined us?
Yes, partially.
Okay, I'm going to make the slide available, and yeah, so you can look through it. And my email is there. If there's anything that is not clear to you, feel free to contact me, and I'm happy to explain further and chat about it.
Thank you, Mr. Adekunle.
Yeah, you're welcome, Doctor. Okay, so moving ahead, yeah. So here I'm talking about deleting unnecessary code. One of the bad habits that programmers have, including myself and so many other people that were trying to, stop doing and cultivate a new one, is keeping unnecessary lines of codes. And I'm going to try to illustrate that with an example. Say, for instance, I'm trying to convert my latitude from degrees to radian. One of the very simple ways to do that is by multiplying that by pi over 180. And that's basically going to convert it from degrees to radian. But after writing this, I discovered that, okay, NumPy, which is a package in Python that is dedicated to matrix multiplication and other things, can actually compute or convert my degrees to radian with an inbuilt function called np.radians. And instead of doing the formal approach, I decided to use np.radians. It's going to give me the same information. But instead of me to delete these 2 lines of code, I put hash, I comment it out, because I'm not sure yet if it's going to give me the same result. I want to double check. After double checking, I realized it's the same result, but I forget to delete it. And if I keep doing this for all the codes I write, I end up having so many commented lines of code in my script. And my script looks like this, which is something at the bottom right. That is, you have more comments than the actual code itself. This sort of script is very difficult to debug. This sort of script is very difficult for somebody else that did not write the script to understand. So it's actually something that is frowned against in the coding norms. You shouldn't do this. If you find a line of code that you don't need, it's better you delete it, you take it out of the script, so that your script can be very clean and easy to understand. And if, for instance, in another dimension, I have actually used this script with convert it to latitude by multiplying by pi over 180. And I realized that, okay, now NP radian is better. Instead of commenting, then I should use JIT for version control. And this is going to be the focus of the next talk. That is, instead of commenting and editing, you can always edit your script and still keeping intact the earlier version, which is what JIT is going to do for you. So you get rid of the fear of, I want to keep my older version because I want to go back to it. Of course, you will go back to it, but you don't need to keep your comment. So if you don't understand this concept now, it's very understandable. It's fine. It's all right. By the time I go through the talk with JIT for version control, that will be very clear to you. But the message here is that don't leave any line of code that you don't need in your script. Delete it. Make your script clean, easy, and easy to understand. So the next idea or the next advice I will give is choose wisely between clean code and clever code. And what am I trying to say here? Now, in this function, get argo flow distance array, I'm looping over a file, which is actually called file in argo files, and I'm getting the latitude and I'm getting the longitude. And from these two quantities, I am computing the distance from the function that we previously defined called compute distance between 2 points. And after that, I am adding this distance to a list in Python. Then after that, I am converting this list to a NumPy array. Now, this looks like a very clean code, easy to understand. If you don't know Python much, you can understand what I've done. But I can actually do this in one line as well. Now, by just saying, putting that in bracket and writing that function, I'm doing all the same thing I've listed above. But then I need to ask myself, I can choose to write it in the format above or in the format below, but who are my audience? Why am I writing this script? Who is going to use my script in the next 5 years? If I am writing this script so that when I become a supervisor, a student of mine, say a master student of mine is going to use it, then I need to go for the above clean code, which is self-explanatory. If I'm writing this code for a community of others that are very skilled in programming language, then I can go with the second line of code. So you need to know how you really want to write your code. Who are the audience? Who is going to be using your code, which is very important. But in a case where you are not sure whoever is going to use your code, then I will advise you to go with the clean code format. It might be long, it might be tedious, but it's much easier because whoever gets a hold of your code would understand what you did and will be able to reuse it. Do we have any question at this point as well?
Not really. For me, the message is clear.
Okay.
Very clear.
Okay, great. So at this point, what is the next thing I'm trying to advise? Now, we need, okay, the objective of this whole presentation is for us to be able to write clean codes. And one of the ways in which you can do this is by looking at source code of softwares that has already been published. And if you are trying to be a professional boxer, you probably want to learn from a professional trainer. If you're trying to be an outstanding researcher, you probably want to learn from an outstanding researcher. So the way to go about learning how to code in a very elegant way is by looking at the source code of software packages that have actually been launched, that have been published. And you can do this by looking at open source softwares on GitHub. There are a lot of them. You can go there, browse through this code. You will see how these skilled software programmers, how they write their codes, where they put comments, where they put, how they label their functions and things like that. And by looking at that, you will have a clear understanding of how you should write your own code as well. And you also understand the importance of why you need to write a very clean and reproducible code. So having said that, I'm going to try to summarize by trying to tell you what are the advantages of writing clean code. And it's very obvious from the presentation that when you write clean codes, problems become easier to solve because you can think of your programming in trying to cut your programming problem into sub-functions. And if you think in that way, it's very easier for you to solve that problem because you give each function a specific task. So if you are skilled in writing clean code, reproducible code, following all the things I've said before, then translating your scientific problem into programming will be very, very easy for you to do. Two, now you spend less time on maintenance because your code is clean, it's well written. You put comment where comment ought to be. You use a self-descriptive name, and by the time you are maintaining your code, probably there are a lot of reasons why you want to maintain your code. Maybe the packages you use in your code has been upgraded. Maybe formerly you were using NumPy 1.4. Now we have NumPy 1.8 with different API. There's a need for you to upgrade your code because your code is based on that NumPy. But if your code is badly written, you don't even know where you have used NumPy. You don't know where you have used some packages of NumPy. But if your code is clearly written, then you know where to go. You know where you have used NumPy, you know where you have used SciPy, you know all these things, and you spend less time wasting your code. Because believe you me, writing a code takes time, but debugging a code takes more time. It's much difficult task to do. So number 3 is ideas are more clearly communicated. If you write a clean code, 1,000 lines of code, 100 lines of code, and you pass it across to somebody else, they understand it easily. They don't have a problem digesting what you've written. If you are involved in a community whereby you are doing software, developing software packages, and you need to write a lot of codes and put on GitHub, then your colleagues will not have a problem understanding your code, and it will make life easier for everyone. So these are the benefits of writing code, and these are not my words. The credit goes to Joel Lee, which has written this, but I find this summary very insightful and capturing all the things that I wanted to say. So that's why I'm putting it on my slide. So that is the end of the presentation, and thank you for listening.
Thank you.
Thank you.
Yeah, do you have any question? Any question?
Ajayi,
nope, it's all good.
Bastien, you want to say something?
Yeah, Ajayi, for me, it's I wrote a little bit of code with a professor, and I know it's difficult to exactly write the same comma and letters and the professor wants you to write.
Okay.
But I would like you to advise a little bit is what are the application? Why should I write a code?
Why should you write a code?
Yeah, what are the field of application? Maybe I lost the beginning of your presentation.
Yeah. So I'm going to put up my slide again, and can you see my slide?
Yeah, I can see.
Okay. So at the beginning, I said I was trying to answer this question: what does programming mean for us in academia? Yeah. One of the things we do when we program is we try to run experiments, we try to solve specific problems. And say, for instance, like I said before, trying to use the environmental sciences as a case study. In the atmospheric and oceanic community, we write scripts to run numerical simulations. We do experiments trying to understand how the ocean moves, how the atmosphere moves. And this simulation is based on scripts that have been written, thousands of lines, 2,000 of lines, based on Fortran code. So writing codes is useful for performing numerical simulations, experimenting on our ideas and things like that. Also, when you run this experiment, you churn out large set of data set, a large scale of data set. In my laboratory, we just finished running a North Atlantic simulation that just dumped about 2 petabytes of data set. That is huge. 2 petabytes of data set. You need to be able to write scripts that are consistent with high performance data analytics to be able to analyze your data sets. So you need to be able to write clean codes, reproducible codes. You need to be able to put your codes on cloud so that everybody can make use of it. And if you're going to be doing that, then you need to be skilled in the act of programming to be able to affect a larger community of people with your script. So we do that because we need to do data analysis. We write codes because we need to do data visualization. Because we have this data set, we need to make sense of it. We need to present this data set to people. How do we do that? In form of visualization. You want to show the map of the North Atlantic, you want to show the map or the way the atmosphere is moving with respect to one or two other features and things like that. We do that by way of visualization. And these visualizations are based on codes, Python codes, R codes, whatever language you're familiar with. And also I spoke about software development. Now there's been a growing community of geoscientists that have been involved in software development, trying to build packages that are dedicated to solving domain-specific problems. For instance, I don't know if you've heard of XArray. XArray is a Python-based package that tries to do analysis of geoscience problems, like trying to plot the North Atlantic, trying to do analysis with geoscience data set. So things like that. If you are not skilled in programming languages like Python, C++, you cannot join that community of open source volunteers that are developing XArray. So there's a lot of applications for writing codes. And in simple terms, if you are in the scientific field as a master's student or as a PhD student, from the beginning of your master's to the end of your PhD or throughout your career, you'll be writing scripts because you'll be doing analysis, you'll be doing data visualizations and things like that. I don't know if that answered your question.
You know, it's a little bit. In our room, there is only one guy who codes, but he's not here. But most of the time we use software where I guess the code is already written for us. So we're making maps. I've been for all my PhD by clicking a lot. And in my field of making maps, to translate a notebook into the computer, that can do that. I need to do that manually and actually scan and digitize the contour myself.
Yeah.
So I think there's a little bit of a gap, for example, in my field of geology and in the field of programming. That's why my question come in. But I think you are right. Many of the students here, they start more coding and we miss your talk, but I think it's very needed. So we are they're asking if it's going to be available online, and we're really looking forward to getting all this information.
Yeah, and to say one thing, in reality, the software that you are using that is based on one click is actually a product of many lines of codes. And whether you like it or not, that software in the next 5-10 years would be outdated and has to be improved. And somebody with a programming skill will have to do that. So as a matter of fact, many of the one-click softwares that we have now, there's a community of scientists, or if it is open source, or if it is private, there are scientists that are also trying to improve these packages on a daily basis. So what I'm just trying to say is that some people have committed a lot of energy trying to code that packages so that you can do a one-click. So I agree with you. Yeah, it still boils down on the skills of programming.
Yeah, just to add to that, I think it's always a useful skill to have. Behind all the software that you or the application that you use is a code, like you said. So if you can start introducing students into doing, even if it's a little bit of a knowledge in this area, I think it's going to be a useful thing down the line. Yeah. So which is why we're trying to have this kind of introductory talk. And of course, if any of your students, Bastien, is interested in learning a particular code, I think that person should maybe suggest, let us know. Kunle or anybody on the platform will be ready to give that person some resources to help the person learn. There are a lot of online, even textbooks or PDFs that we can easily download and send to that person to help that person learn. So I just want to add that to the comment. All right, another question? Yeah, Bastien group.
Adekunle, tell me, do you have any experience in coding with R?
R?
Yeah.
Yeah, I do, but I'm not as skillful in R as I am in Python.
Okay.
So
Have you worked with spatial data sets in R?
Okay. Yeah, but if you need help, I can still provide help. If you need help, if you need resources, I can provide resources.
So do you use R? Is that what you're saying?
Yeah.
Have you worked with spatial data sets in R?
Okay. I think Kunle might help. Kunle, if you can write that down and kind of send across to everyone.
Yeah.
Resources
Sure.
about her. And I think Marie is also online. I don't know. I think she said earlier that she uses her. Marie, can you unmute yourself and let us know if you do use her and if you can learn some help here? Marie, go ahead.
Hello.
Hello, yeah, we can hear you.
Yeah.
Do you use her?
I did use it 2 years ago. I'm not using it usually, but I can do little analysis.
Yeah. So one thing I might suggest is that you can send across a message to everybody on the platform, whether it was on WhatsApp or through the email, and then they can help you with a specific question or specific help that you might need. And obviously, Kunle will be available to also provide some help too. Kunle, go ahead.
So I just want to say that whatever problems you have or whatever you're trying to do, you can just be very specific. I'm trying to do analysis in spatial, blah, 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 on the group. And if anybody is I've done something like that, they can provide help in that area. And also, I have a couple of resources that is specific to computing in R, so it won't be a problem finding a solution to the problem that you have or what you're trying to do.
All right. Any other question?
Yes, I have one question.
Okay.
Henry.
Yeah. Yes. Mr. Adekunle, thank you for your presentation.
You're welcome.
Yeah, my question is how to develop the mindset of a programmer. I understand that programming is not just knowing how to write the syntaxes that the computer will be able to understand. Mm-hmm. You also know how to dissect or break down, problems such as the ones we have in environmental sciences, and be able to represent the solutions or the problems themselves in form of codes. So how do we develop this mindset to be able to at least be able to solve these problems using computer codes or programs?
Yeah, I think, like I said, if you're trying to solve a scientific problem, the first thing you want to do is try to develop an algorithm. And developing an algorithm means that you need to try to understand your problem and try to translate into maybe mathematical model or mathematical function or logic or anything before you can start implementing it using programming languages. So having the mindset of a programmer comes with experience, comes with number of problems you have and how you've been able to tackle it. But from my own experience, what I realize is if you're trying to solve a particular problem, you need to try to translate into what it means mathematically, what it means in terms of algorithm. Say, for instance, I have a very, like the example I showed, I have a very big data set. And this data set contains a lot of files with latitude and longitude of Argo float. And I want to have the distribution of the distance covered by this Argo float. The first thing I need to do is, I know I need to have a program that computes the distance. Then I need to have a program that loops over these files, that extracts out this longitude and latitude and compute the distance. Then I know I need to have a program that computes the statistics of this distribution. So if you think of things in bit by bit, you don't approach the problem like top to bottom. You approach it from bottom to top. You need to segment it carefully and say, okay, what are the components that makes up the solution to this problem? I need to read the file, yes. I need to compute distance, yes. I need to be able to compute the statistics, yes. And that is going to give you an insight into the numbers of functions you need to write, and that's going to give you an insight to how you want to connect them together. So the same thing goes to any problem that you have that involves programming. You think of it, this is the solution. How many parts does the solution have? then if you can get that straight, then it will be very much easier for you to start writing the functions to solve each task one after the other and combining them together.
Okay. So it comes from practicing.
Yeah. And carefully looking at it, carefully looking at the problem, carefully developing an algorithm to say which one comes first. What do I do first? Of course, I know I need to compute the distance before I can compute the distribution of the distance. If not, it doesn't make sense. So you need to look at things bottom to top and try to build it carefully, one after the other.
Okay, thank you.
You're welcome.
Any other question? The last question before we go?
Yes, I have a question.
Yes.
Generally, people are asking about which is the good program. Before in the beginning of your presentation, your introduction, you talk about PHP, Python, R, C++.
Yeah.
So according to you, which one is the best in general, and which one is easy to use?
I think what you're asking me is like saying, we have English language, we have Chinese language, we have French, we have all this. Which is the best language? No, it's not possible. You only use the language when you are in the community that warrants you to use that language. If I'm in France, I have to speak French. If I'm in the US, I have to speak English. If I go to Chinese, even if I don't speak Chinese, I need to find my way to make people understand me, maybe by Google Translation or something like that. So these problems have these programming languages have their strengths and weaknesses. So you need to look at the problems the problem you have, what you want to solve, and look at the programming language that is best fitted for you. That's one. And two, you also need to look at which one am I very skillful in. For instance, if I'm supposed to join a software development team today in writing codes, I prefer to write my codes in Python or MATLAB rather than maybe using C++, because I know I'm better off in Python or MATLAB. So it's not about which of these programming is the best. It has to do with which one do you know best and what is the problem you're trying to solve.
That's a very good answer, Adekunle. And also sometimes I think, just to add one last line, it sometimes might be useful to also, if you're working in a group, like a large group of people, there might be a designated code. So you definitely have to learn that. And in that context, that's gonna be the best code to use, because that's gonna be the preferred code everybody around you can understand. So, but I really want to thank everybody for that, especially Kunle for giving this awesome presentation. And I want to ask everybody, is this something that you're very interested in? By that I mean, are you interested in him talking a little bit more deeper into even the basics of coding and some of those things? Is this something that everybody's interested in? I just want to gauge the idea, the interest. You can talk if you can unmute yourself and talk if you like.
Yes, I'm really very much interested in codings.
So you like to hear more of, or have another lecture like this, another?
Yes.
Like this. All right, great.
Yes.
Anybody else?
Yeah, me too. I would like to know more about coding, especially the basics, because I'm still in elementary research. So I was, yes.
And I imagine that Bastien's group is also interested, right, Bastien?
Steve is going to speak for the group because he's doing some special analysis and he's coding a lot.
Yeah, no, definitely. Let's keep the conversation going.
All right, awesome. Okay, so I think definitely we are going to have Kunle. Somebody also online also said, Nia, lots of people said that he's interested too, that he would like to hear more about it. So yeah. So I think we're going to have to again to give us a little bit of another brush. Perhaps we might extend this to a 3-part series if Kunle doesn't mind. So
let's see how it goes.
Yeah, I know. Thank you very much, everybody. Yeah, I know that a couple of us also joined sometimes in between when Kunle already started the talk. So we're going to make the presentation available. And while we are also talking, I also took the liberty of recording the talk as well. So we're going to have an actual video presentation also uploaded either on YouTube or on Facebook. So I'll also be sending a link out for that one as well, so that it's easier for people that also want to go back and maybe even hear the questions that other people have. So that's going to be a good thing. So thank you, Kunle, very much for this awesome talk. And I think I learned one or two things from it too.